and volume inside this engine, there should be a gas in there. So what gases are inside this engine here during the different parts of the cycle? Now, what do you think's coming in? What's going out?
I know what's going in.
What's going in?
Air, molecules.
All right, molecules of air going in. Is it coming out?
Gasoline.
Oh, where does that come in? That gets mixed in with the air as it comes in. All right, so let's talk about this because I think a lot of us are not sure, right? Is that pretty much the consensus? We're not sure what's going on? So let's think about at least what we do know for sure. So what do you know? What's going into the
air?
Okay, so we have air enters in here. Now it's going down here in the intake. Does it change here?
Yes.
So what do you mean by yes, it's changed?
The colors.
So this is air here. See, okay, if you watch the animation here, look, watch carefully. Ready? Now. So that air came in here
It's getting mixed and then it gets pushed out.
with gasoline mixed with it. Okay, so air, and we have some gasoline that's dispersed in there. And now, I'll wait for it. So we've taken it in. Now we're just compressing it. Did we change the type of gas that was there?
No.
Okay, no. So intake and compression both have just this mixture of air that it's taken in and the gasoline. And then combustion happens. What does combustion mean? It creates an explosion. And so
That's what gas is. Gas.
Oops. This is actually, let me move this here. It's kind of in the way. Okay, so combustion actually is a chemical reaction that happens inside the engine. So we take, this is our gasoline or our fuel, and we add it to oxygen. And then we get out carbon dioxide, water, so water vapor, and heat. That's produced by combustion. So that's the explosion reaction. So we take this fuel, and we add oxygen, and it creates this explosion that you're talking about. And you get out carbon dioxide and water and heat. Sometimes the combustion is not complete, and so instead of getting out carbon dioxide, you get out carbon monoxide, also as a gas that would come out. So see, this one's carbon monoxide. So that could also be released during that reaction of combustion. So now let's go back to your entry question and tell somebody next to you now what you think are the gases that are present for each of these 4 parts of the engine cycle. Okay, so tell somebody next to you what's in that engine for stage 1, 2, 3, and 4 of the cycle. So what do we have going into our engine? What gas is going into the engine?
Fuel and oxygen, carbon dioxide. Fuel and air.
Coming into the engine
Oh.
right here,
Oh yeah.
through the intake port, what comes in? Air comes in, and we also get some of the gasoline mixed in with the air. Then it comes down, it compresses, and then it combusts, and we get this reaction right here. So right now, what gas do we have right in here? Carbon dioxide, and what gases do we have? Carbon dioxide, and we have this part right here. Carbon dioxide and water and heat. And you might have carbon monoxide also coming out here. And that's also what exits from your exhaust. So this is what we take in. These are the gases that are during the second half of the cycle, during combustion and the exhaust stroke. So the whole time we have this phase of matter, this gas in our engine, But it's not always the same gas. We've actually converted it from oxygen into carbon dioxide and water. And then we also get this heat coming out. Okay, so what happens during intake? Who wants to describe what's happening during intake? Volunteers? Johnson, why don't you give it a try? What's happening during intake?
Air is going in, so then there's more volume.
Okay, so we have air entering in. And so we're increasing the volume of what?
Piston.
The what? Okay, so the volume that air can take up inside the piston. What else changes? Does anything else change?
Pressure.
Does pressure change? So I see some heads shaking no. Why does pressure not change here?
It's the same as outside.
Okay, why is it the same as outside?
Because it opens the valve.
Yeah.
Okay, so the valve is open, just like our pop can. We have this open system, and so the air that's coming in, we're not changing the pressure during that stroke. So what happens during compression? Who wants to tell us what happens during compression? Kirsten, why don't you tell us what happens during compression? What? Okay, well let's look at it then. So right now, what's happening inside this piston? What's happening to the pressure or the volume or the temperature as I do that to it?
The volume gets less.
Okay, so the volume is decreasing. All right, and what else happens?
Well, I was going to say pressure is increasing, but that valve's open.
Is the valve open?
Yeah, right there it is.
Okay, so we're going to watch, now we're doing compression right here. Are the
Oh.
valves open?
So yeah, pressure is increasing.
Okay, and why is pressure increasing? It's just like my syringe here. If it's closed and I squeeze it down, why is pressure increasing?
Because there's no way to
So
go.
the molecules are there.
The molecules are in here and what? They're hitting the walls and,
There's nowhere to go.
okay. So that increases pressure. If I decrease volume, I'm decreasing the space for those molecules to be in, and so we get more collisions. What happens to temperature?
It gets higher because it's moving faster.
Okay.
That's
So
pressure.
we have a high temperature, we have more compression here. And now we have this ignition, the spark, and so we get combustion. So tell somebody next to you everything that's happening inside right now during the orange part here, phase 3. Tell somebody next to you what's happening during combustion. Okay, so what happens during combustion?
Heats up, combines.
Okay, so what?
Combines.
What happens? What combines?
All that stuff.
So we get this reaction. We get the fuel and the oxygen to react, and what happens to them?
Carbon dioxide.
Turns into carbon dioxide, and
As with H2O.
okay, and so it puts out heat. So what does heat do?
Changes the color.
So it looks different, but what happens actually to the gas in here when heat is released from that reaction?
Gives you power.
And what gives it power? Or how can you tell there's power?
Exhaust.
Pressure.
Okay, so what about the
Yeah.
pressure?
It increases the molecules faster.
Okay, so when I add heat to the system, we're going to increase the temperature, and so what does that do?
Pressure.
Why?
Because the molecules are moving faster.
Okay, and so why does that make more pressure?
It's hitting the wall. Yeah.
I love this. We have, he'll say pressure, and he'll say hitting the walls. So if you ever, it's like this little choir, I'll say,
Pressure in the wall.
okay. So, okay. And then we've increased the temperature, which increased the pressure, which increased hitting the walls. And did, what else changed? One more thing.
Volume.
The volume changed.
Pressure in the
So I
wall.
get bigger. Who wants to be the volume part of the choir?
Maybe I'm not.
Okay, so now let's talk about stroke 4, the exhaust. Tell somebody next to you what's happening during exhaust. What's changing and what's coming out of the engine.
Everything's coming out.
Everything that's burned is dead.
Everything just got shut off.
Okay, volume's decreasing. We have an open valve here, so we have pressure that stays the same because, and what's leaving? Carbon dioxide and some water and maybe some carbon monoxide if you didn't have the full reaction. The engine takes energy from the fuel and from the oxygen, and during combustion it turns it into this heat, which we know then raises the temperature, which makes the air expand, and so we get this horsepower. So the more fuel we have and the more oxygen we have to combust, is more power that we can get into our engine. So a lot of the things we're going to be looking at today, you're going to try to analyze how is it getting more power from what you're adding on. And you always want to be looking for if it's adding more oxygen for this combustion reaction to be happening inside your engine. Because that's our goal today, is to increase the power of our engines. You're going to be working with your group to add some modifications to an engine. And so your task today is with your group, you're going to be doing this. You're going to be explaining 4 different modifications that you can do to a car in order to make it into a better kind of race car. Lots of power, okay? So on your paper you have the tire pressure monitoring system. You all have to install that. So you have to say why you would install this tire pressure monitoring system. Why would it be good if you're racing a car at high speeds to have a pressure monitoring system in your tires? Okay?
So you go slower if it's going to explode.
So you need to tell me why using temperature, pressure, and volume of the air in that tire. Okay? So that's your first job. As a group, you're going to explain why it's really important for us to install this as our kind of safety feature. Okay? And then you have $1,000 more based on these fake money. $1,000 to spend on your modifications for your car. So you need to pick, I want you to spend as much of the money as you can without going over. And you need to install at least 3 modifications, okay? So you can pick between, you're probably going to want to pick one of the higher priced items and then a couple of the lower priced items.
No.
Or pick all of the lowest price items, or pick all of the highest.
Maybe. Okay, so for each item you decide to buy for your car, you should use the following format to explain why you bought the item. Okay, so you're going to be on a poster with your group using this format to explain why you would get it. So let's say you try to pick the, tell me a modification to pick here.
Supercharger.
Supercharger. Okay, so this has a little quick description of it. Over on the counter over there are a much fuller description of each of the different types. So if your group decides to pick a supercharger, you're probably going to want to go over to the counter and get some information about superchargers. Read a little bit more about it. But it says turbochargers and superchargers pressurize the incoming air to effectively cram more air into a cylinder. Many manufacturers make aftermarket turbos and superchargers for many different cars. Okay, so
Why do you have 2 of them?
what? Oh, they're the same because they both are talking about it. But turbocharger and supercharger are slightly different. And if you want to pick one versus the other, you can read more about it over there. Basically, it's where they're getting their power to do this charging. You can assume that these modifications are not going to blow your engine, okay? It's probably a false assumption, but let's assume that everything we're going to add today, actually you could add and it would be successful.
So you have to install the tire pressure monitor?
Yes. Any other questions?
No, ma'am. You married me?
Did you see the picture?
Yeah, but does it get air from the outside or does it get air from the
Yeah,
inside?
No. Does it matter?
I was wondering.
Yeah, see, that's the one.
So what are we gonna get?
Actually, we should do intercooler and one of these, that we have to do right there.
Yeah.
We could get that one,
I don't think high performance exhaust system is going to really help.
Think about
Because
like,
it's just exhaust. I mean, we're focused really on more horsepower out of it.
No, the exhaust, it makes it go faster. If you have more bigger exhaust, more air goes through, so it pushes the engine faster.
No, there's this relationship between temperature.
What's the point of it? Always does it make the car faster, or
Why is there more temperature?
So we definitely have to have this.
So what about bouncing on?
basically all this makes the car faster.
But we're always supposed to choose 2 things. And we only spend $1,000.
Not only 3 things, at least 3 things.
So if we're compressing the air with our turbocharger. So good. Make sure that when you're explaining them on your poster that you're thinking about each of those. 5, 6, 7, 8. So you're gonna have to probably only either pick your cold air.
So, say intake, tire pressure, intercooler, and supercharger.
Okay, is everybody at the group okay with this? Are you okay with this? What's wrong? Are you tired? So, and are you okay with this? All right. So then, what's your next step? What are you gonna do?
Okay.
All right. So why don't you start talking about it together? Pick one of them and start explaining how it could increase the power of your car.
Wait, we just pick one?
Well, you're gonna do all of them, but just start with one. And how about why don't you? There's an extra stool over there. Why don't you just go and come sit across so that you're concerned? So why would that be important?
Because you just called it a safety feature.
So why did I call it a safety feature?
Because apparently it's going to help us be safe.
Okay, how will it do that? What do you think? Let's talk about temperature, pressure, and volume of the air in our tires as we're racing it around.
Might get low.
What?
The pressure might get low.
Why?
And then,
What would cause the pressure to get lower?
I don't know, too much driving or something.
So if you're doing a lot of driving, what are you doing to your tires?
Wearing them out.
Okay, and what else might you be doing to them?
Making them lose air.
Lose air?
Putting force on it, so then the pressure is lower.
Okay.
We're putting force on it so the volume decreases.
And what else happens with your tire as it's like going along the road?
Traction.
Traction?
I can't figure out the word that I'm trying.
You're about to say it.
Friction.
Yeah, friction. So what does friction do to your tires?
It decrease.
What?
What do you mean by
No, I mean not decrease. I'm sure I'm thinking of something else. What?
So I have friction going against my tires. What's it doing to those tires?
Killing the tires. I mean, it's like breaking apart the tires.
Okay, and could it be doing anything to the inside of the tire?
Not really. Having the air move around.
So air moving around. Why would air be moving around?
Because the car's moving.
Okay.
Well, because air's a molecule and it's gonna move.
So is the speed of
It'll probably slow them down because there's so much friction. If you drive a lot, you're gonna have more friction, and it'll probably slow down the air molecules inside of it, causing less pressure.
Okay, so
I'm like, I don't know where that
if
just came from.
slower molecules would be less pressure. But if we have this wheel and we have air trapped inside of it and it's moving along the road and we have friction, what does friction cause? What's released?
What's released?
Can temperature change
Yeah.
inside your tire? Okay, what might cause temperature to change inside your tire?
Friction, it'll heat up, making your molecules move faster.
Okay, so if I'm racing my car around and I have lots of friction going on, and you increase the temperature,
You're gonna have more pressure inside of your tire from the air.
okay, and what would happen to the volume inside your tire?
It would expand.
Why?
Just trying to hit the walls.
Because that's how God made it.
That's how God made it. That's a good answer.
Thank you.
Okay,
I tried to.
so it's expanding because the pressure and the molecules are moving around and putting pressure on the walls of the container.
For real, Mr. Honda Man.
So why would this be helpful?
You know if your tires are going to get worn out or something?
Worn out or what else?
Like deflate or whatever.
For explode.
Or, yeah.
Okay, so what? So if I'm racing around, why might my tires explode?
because of the friction.
And what does that do?
It creates heat, and the heat makes the air molecules move faster, creating more pressure, which makes the volume increase, which makes your tire explode.
So that's why it's a safety feature.
There you
So I
go.
gotta write that.
Hey.
Makes more air in the cylinder, right? Makes it more pressured, more molecules in the cylinder. Therefore, the number of molecules won't be able to rapidly move around because they're more compact. So therefore,
Yeah, you guys have me thinking about
the temperature will probably decrease because they're not moving around. You know what I'm trying to say? Okay, I don't know. I'm just guessing. But I'm saying that more molecules, there'll be less space to rapidly move around, causing not a lot of temperature. I mean, heat. You understand what I'm saying?
And you're working on supercharger? So what do you have so far?
I'm working on the first one.
Okay. So during the intake stroke, the number of molecules increased.
I'm just saying the same thing. Because the supercharger compresses the air, so there's more pressure, but
There's less volume? So each like section of air molecules would take up less volume.
They would be compressed so they're closer together, so you can fit more in.
And what one are you working on?
Intercooler.
Okay, so what do you have so far?
For the first one, about the number of air of molecules I put is decreasing compared to the regular engine because it's decreasing the temperature as it cools the compressed air.
Okay, and so how does that decrease the number of air molecules?
Because as it's cooling down, it's not using as much air molecules. Right?
I'm thinking about it. I have to think about it. So I have some air that I'm bringing in. So the intercooler, where does that go on a car?
In the front,
And what is it attached to?
it's attached to the engine and the supercharger.
Okay, so do you know what order it goes in? Like where would those two pipes on that intercooler be attached to?
One would be
Probably this one
attached-
be the engine, this will be the
Would
supercharger.
it go to yeah, that's right.
Okay, so I'm taking this air from my supercharger, I'm cooling it down, and then I'm putting it into my engine.
Yeah.
So if I cool air down, what am I doing? To describe what's happening to the molecules.
It's slowing down,
Okay.
but it's still kind of the same amount of molecules. I don't know. Because when you cool it down, don't they go away?
Go away.
Or like, not go away, but like,
They're slowing down.
they're not as fast.
Okay, so they're not as fast, they're not moving around as much. So does that increase or decrease the amount of air I could fit inside of my, or the increase or decrease the amount of molecules that we could put into the engine? If the molecules are moving more slowly. So if temperature decreases, why would that decrease the amount of molecules you could put in?
Is that wrong?
I want to think through it together. So if I'm slowing down the molecules,
Yeah.
they're moving more slowly. So could I put more or less in if they're moving more slowly?
Yes.
What do you think?
More.
Why?
Because they're not moving around as much, so there's less, so that they're, it's like in the supercharger they're being compressed, and so this is like they can compress even more because they're being slowing down. They're not moving as fast. They're moving less, so they're just closer together. So they're going from like this to like this.
So you can put, so if I'm going like this all crazy, am I taking up more space or less space? So then what can I, if I am moving more slowly, could I put more or less air in now? Yeah, more.
That's when the gas and air is going in the cylinder, right? The temperature of the air in the cylinder increases or decreases compared to a regular. So the nitrous puts in more air in the
on a cotton filtration
Increase.
technology design.
So it increases?
Yeah.
Because, but the temperature, what happens about the temperature? Does it increase or decrease? When?
Increases.
Why?
Because the gas is fuel, so like in air, it's going faster, so the faster it is, the more heat it's going to produce.
This media is then
So what's going to happen if I add more oxygen to my engine? So it's going to make it faster. Why? Okay, so tell me more about that, Rika.
well, because there'll be because there'll be more air in there. It'll be like more molecules to combust.
Okay. Okay, so if I have more oxygen, so if I increase the amount of oxygen here, I can increase the amount of fuel that I add, and I can get a more combustion. So if I get combustion, what comes out over here? What do we get from combustion?
Carbon dioxide.
And water, and the most important part is the heat. So what does heat do to in our engine? When we get this big boost in temperature here because we've combusted. It speeds up the molecules, and what happens to the actual engine?
Speeds up the gets more power.
It gets more power because what happens during the
Faster.
what's faster?
The speed.
And what dictates or what causes you to be going at a faster speed?
There's more.
Like relate it back to the engine. What's moving in the engine when we get more heat? Okay. And so the piston's moving more because you have more what? More heat. Because you were able to do more combustion. If you're able to get more oxygen into your engine, then you can also put in more fuel. So you get this more rapid combustion and more heat and more movement of that piston, like you said. So I want you to keep that idea in mind today as you finish your posters. I'd like you to finish them in about 20 minutes because at the end I'd like us to share. We'll let every group present before we go today, so even if class is technically out, we'll finish up. So make sure you're paying attention. The quicker you pay attention, the quicker we can have everybody share.
All right, let's go.
Go ahead.
I picked intercooler.
And then we also pick supercharger. We're going to choose doing test choosing okay. For the supercharger, we chose this is the supercharger increase the power of the car because it compresses the air going into the cylinder. There's more air. This is during the intake stroke, the number of molecules of air in the cylinder increased because the molecules are being compressed together, so they're taking up less space, so they can fit more in. And the temperature of the air increased because the molecules are going through the supercharger and they're being compressed. And
so why does compression mean more temperature?
Well, I just assumed that it was being heated because you have to have you need an intercooler.
Okay.
You need an intercooler for the
So if the molecules are closer together, how does that make them have more temperature?
They collide more.
Okay. That would be pressure. What does temperature measure?
Speed.
Okay.
No, speed.
Okay. Okay.
And in the intake stroke, the pressure of the air in the cylinder increased because more molecules are being forced into the cylinder.
Okay.
And for the compression stroke, the pressure of air in the cylinder increased because there's more molecules. And the rate for the combustion stroke, the rate of expansion of the air increased because there's more molecules and they're being heated up more, so that they're expanding more.
Okay.
And the pros and cons of this is the pros, there's more air, so there's more oxygen and there's bigger burst of energy. And the con is the temperature would be hotter in the engine because if you don't have an intercooler.
Okay, good. Let's give them a hand and running your groups up.
The nitrous oxide increased the power of the car because it delivers high amounts of oxygen to our engine. During the intake stroke, the pressure of the air molecules in the cylinder increased compared to a regular engine because we're forcing more oxygen into the engine, so there'll be more air. During the intake stroke, the temperature of the air increases because there'll be more molecules, then there'll be more collisions, and the pressure will go up. And during the intake stroke, the pressure of the air increases because there's more molecules, more collisions against each other and against the walls. And during the compression stroke, the pressure of the air increases also because there's more molecules in there than there would normally be, so it'd be even harder for it to compress. And yeah, you guys can help me on this one. During the combustion stroke, the rate of the expansion of the gas in the cylinder.
Yeah, during combustion, what would you expect?
Like when it explodes.
It would? It
I
would.
mean, no.
What?
It's not gonna.
Will it increase or decrease? It will.
So you have your NOS and you've added more oxygen, you've compressed it, and now what's going to happen?
It's going to have a bigger combustion.
Why?
Because there's more air molecules in there, and
Okay.
there's more fuel.
Okay, and so then,
Our combustion is going to be bigger.
okay, good.
And the pros and cons of this, the pros would be you go faster, more air in your engine, so you go faster. And the cons would be that you could possibly explode your engine.
Okay.